an article published on December 14 in the journal Science, the researchers revealed that these strange droplets emerged in the strange and microscopic world of a laser network, an optical structure used to manipulate quantum objects, in a laboratory of the Spanish Institute of Medical Sciences, or Institute of Photonic Sciences ICFO. And they were real liquids, substances that maintain their volume independently of the external temperature and form drops in small quantities. That is unlike gases, which expand to fill their containers. But they were much less dense than any liquid that exists under normal circumstances, and they maintained their liquid state through a process known as quantum fluctuation. The researchers cooled a gas of cooled potassium atoms to -459.67 degrees Fahrenheit (-273.15 degrees Celsius), near absolute zero. At that temperature, the atoms formed a Bose-Einstein condensate. That is a state of matter where the cold atoms clump together and begin to superimpose themselves physically. These condensates are interesting because their interactions are dominated by quantum laws, rather than the classical interactions that can explain the behavior of most large volumes of matter. When the researchers pushed two of these condensates together, they formed droplets, coming together to fill a definite volume. But unlike most liquids, which hold their droplets together through electromagnetic interactions between molecules, these droplets maintain their shape through a process known as quantum fluctuation. Quantum fluctuation arises from Heisenberg's uncertainty principle, which states that particles are basically probabilistic. They do not have a level of energy or place in space, but rather they are joined at several possible levels and locations of energy. Those stained particles act a bit as if they were jumping around their possible locations and energies, applying pressure on their neighbors. Add all the pressures of all the particles that flow, and you will find that they tend to attract more to each other than to repel each other. That attraction unites them in droplets.